Today is going to be very fun. So, last time we had miraculously repurposed our MNIST neural network to learn from the transcripts of Final Fantasy VII how to speak English. We trained it for a couple minutes and saw some pretty interesting results. Since last stream, I've trained it on a much bigger network. So here I'm using 20 characters as the context window, 3 hidden layers of 800 ReLUs each, and then still single character prediction. I let that run for a few hours, and there's some stuff to learn about it. So first of all, this is the this is the run. So it starts after the very first epoch at 50%, 49.91. After a few epochs, it goes all the way up to 54.16%, which is crazy high. This reminder means on text that it's not seen before, more than half of the time, if you give it a string of 20 characters, it can accurately tell you what the next character is going to be. So it hits its peak after 4 epochs, and then it slowly goes downhill after that, very slowly. We, at a certain point, our decay schedule for the learning rate kicks in, and because the peak was so long ago, at every single epoch it halves the learning rate. So we're basically not doing any learning as soon as this kicked in, and that's what it was for half of the entire training run. So that's not good. I've got a list of goals for today based on that last run of things I want to accomplish. So the first one is I want to be able to say, okay, I'm done training. Let's just use the, let's pause training and let's just start using it, which I was not able to do. So I could already tell at the halfway point after 2 hours that it was not going to learn anything new, but I had to let it run for 2 more hours just to be able to not throw away the work that I've done so far. Decay schedule, bad. It's not good that it does this. It falls into this trap where it just commits to wasting its time for the rest of the run. Not good. So we're going to update decay schedule. I don't know in what way, but we're going to make a schedule that makes more sense. The other thing is it's kind of, well, maybe this is fine, actually. I was going to say let's change the progress bar so that it shows so that it doesn't do this thing, so that like the progress bar updates itself instead of adding a new line. But come to think of it, it actually is nice that I could look back at the run. So I think I'm not going to do this. And then save and load. So the other thing is, if I kill this, my model that I spent 4 hours training is just gone forever. So I want to add saving and loading so that that's not the case. But I've kept you in suspense for too long. So let's play with this model. I only did 2 tests so far, and I was very impressed with both of them. So the first prompt that I tried was just saying cloud:"I", because the dialogue always starts with a person, colon, and then something that they say, and I is a very common beginning of a sentence. So just to see what it would say if I did that. Cloud, I, what, ... wonder, make sounds understand. And then Bugenhagen says, the story of the planets, ... and those who live. And then I cut it off. I arbitrarily say only generate 100 characters, but I could generate more. Maybe I should do that, actually. Because I'm curious what it would have said if I let it keep going. Let's say you get to do 250 characters from now on. And then I did Eris I as my next prompt, and it said, Eris, I know that's that ... We would enemer. We've got to happen to be in the place. But with the Shinra, notice capital letter after a period. Shinra, that's a a word you can only learn by reading Final Fantasy VII. So let's play with it some more. Hello, my name is... Hello, my name is Noregelfors? And then Reno responds, thanks, to be sure that Beggar and Deezy in the slums to get up. We're cave a mind. I work for nothing for you. NPC, welcome. Sit wherever you like. NPC, have a seat over here. NPC, yes. What will... I want to join Thing the new me it a vig shapt of Surl special Vilda. Clothes that was all right. Why do you think... So even when it's writing gibberish, it's inventing words that look kind of English-like. Vilda, shapt, vig. Those could be words. They're not. It hallucinated them, but it still like gets the vibe of English. What's the vibe of English? The Teepers and Predator. Who cares are what you'll have this of materia would gratin. This is a counterexample. That's not an English looking word. I'm joining Ava. Avalzing. We nold to go other in last time. This is the lounge floor. Above us are the special. So is lounge floor in the dialogue? Because that sounds... Yeah. Oh, so it memorized this line. Above us are the special floors. What if I prompt it with this? What else did it want to say? Above us are the special floors for the bigwigs in the company. It's tough working under someone. So it memorized stuff. Like in these giant matrices of weights and biases, it memorized a bunch of dialogue. I wonder how much of it it memorized. I wonder if it's about the plate incident. NPC sitting here facing the monitor. I wonder if it memorized the whole text. Is there anything it doesn't know? The Dawn's not into men, so don't let me catch you around here again. Guard, hey, and you got another cute one with you. It looks like it memorized the whole text. But don't get lazy now. That's so cool. Is that overfitting? I think you could probably say that's overfitting. I live in Sector. It's just so fun to... Sector 7! It knows! That was something I was trying to get it to do before, and I never was able to get it to say Sector 7. the sectors are them. Sector 6 or... Okay, it doesn't know... I'm trying to get it to say 6 or 7, which would mean it's like internalized some concepts of English. Anyway, that's super cool. It's just really cool. My name is Red 13. Okay, I'm gonna kill this. And let's start to do some of this stuff. So let's gain the ability to stop training without killing the whole program. That's gonna be easy. We're just gonna put a catch. So try to train, accept keyboard something. Let's actually just see what happens when you, oops. So let's start training and then kill it. Keyboard interrupt. Keyboard interrupt. Print paused training, or stopped training, really. Actually, let me kill that because this is going to take too long. A single hidden layer, 80 neurons, just so that we can see a result. Oh, the other thing is I tuned some of the hyperparameters. Not scientifically, I just kind of tried a few things and saw what was good. And I ended up turning down the regularization a lot. Which may be why it's able to memorize the text now. But yeah, I don't actually know if that's a good thing or a bad thing. I also turned down the momentum coefficient a little bit. I think this is at 0.4. Okay, so we're in the middle of training. I'm gonna just stop the training. Hello? Yeah, okay. So I'm able to stop the training partway through. Good. Let's check this off. Decay schedule more reasonable. So this was not good, what it did. Then this is bothering me just because this is should be 87. This is 87. And this is however many it is. And maybe more than one. So I've got this thing constant schedule that will never change. I do want the learning rate to go down once it stops learning. But I don't know what a good rule would be. So just to remind ourselves, this rule is if the best, where is it? If the best we've ever done is not in the last 10, then we have. But that's not good because, like, we saw in the last run that we had a fluke where the best was really early. So now the best is always not in the last 10. I just want to know if we're getting better. So maybe I could say something like, if the average of the last 5 is higher than the average of the 5 before. Does that make sense to do? Maybe, I'm not sure. The other thing I want is a timeout before you have again. Okay, so let's try the average thing. I'm just going to remove this because it's hard to read. I don't need the best anymore. Yeah, just remember the recent. How was I doing that before? Like this. So if self.recent, the first 5, and then I want the average of that. Can I do mean in Python? Python mean of 1, 2, 3. No, math.mean from math import mean from math import average. Okay, I'm sure there's something like that. Python average. You just calculate it yourself. Okay. So if sum of these divided by length of just 5 divided by 5. Let's just confirm that that is actually 5. 1, 2, 3, 4, 5, 6. Give me up to 5. That is 5. Good. And then if I did starting at 5, as long as I have 10, that's also 5. Okay. Old average equals this. New average equals the later half. If new average is less than old average, self.eta divided by 2. The other part is a timeout, so you can't just now you have to wait before you can keep reducing it. So self.timeout How about we say it's 5? Self.timeout plus equals 1. So every time you have it, or equals 5, I should say, you go back to 5. Every time you do anything, you count down. And only if you have counted down all the way are you allowed to do the decay. Okay, let's test this. So if name equals, the name in main lies mainly in the Spain. Decay schedule, eta equals 100. Schedule dot, what is it, update. Okay, and then let's just print self.timeout as our first test. Let's run this Python learning schedule. So it looks like the timeout goes down and then it activates here, which it shouldn't. I guess it's doing that because we don't have enough examples. So I should also say, I guess I can just start the timeout at 10, actually. Okay. So the timeout only becomes available after 10. And it never decays. Let's also print here self.eta. Okay, so it never decays. So now let's say it got better here. Okay, so it shouldn't decay here, but it should decay once you get here. Or actually, it'll decay immediately once you have once this one is in the old. So that would be, this is the old, this is the new. Yeah, that looks like what it's doing. Okay, and then what if we're improving? 11, 11, 11, 11, 12, 12, 12, 12. Basically, I don't want to see any decay now. No decay, good. And what if we go up and then we start to go down? Or it starts to be unpredictable. So at a certain point, we switch probably before this 12, because this would be the new, which is a little bit lower than this old. This is 53. This is 44 plus 8. $52. Okay. Okay, this is working, and it looks like it's doing what I want it to do. So let's go. I think we probably have a more reasonable decay schedule now. So now save and load. I guess we could... okay, well, the first thing is we need like methods for saving and loading. Maybe we could put these at the top. Save. Load. The thing we need to save is the weights and biases. Maybe we need a file path. We don't need to be able to pause and resume training. That would be cool, but we'll just accept for now that if I save and load, I'm just loading the weights and the biases to be able to prompt. Isn't it crazy that I'm getting to almost 50% with this puny little network? Anyway, save. I want to save a NumPy arrays, right? So NumPy write to disk, numpy.save. So this saves each array as its own file, or no, it saves them both separately. How does it know which one's which? I guess it loads them one at a time. So I guess this is actually going to be really easy. With open path, write binary as f, numpy.save f, self.weights, biases, and then load is just read binary, self.weights equals numpy.load, or this is f. Okay. Let's go over here, and I'll just add the same kind of thing I had before. Try except keyboard interrupt. So when you kill the outer, when you kill it while it's in the prompting phase, now I'm also going to get rid of this because that's not actually, I'm already printing that as we go. It's just making it slow. Okay, so when I kill it while I'm in the prompting phase, I want to ask if you want to save. Print. Save this network, question mark. Save network as. Press enter to skip saving. And then just give me a little input. Name equals this. Then I do net.save. Name dot. Do I get to choose the extension or no? NPZ archive? No, that's save Z. NPY? Yeah, okay. So it has to be .npy. So it's just that. Oh, and if name, it's that. Else. Print exiting without saving. Print saved as name.npy. Okay. Yeah, that's what I want. Then I want a way to load, which is just going to be taking a command line argument. Python command line argument. Import sys. Sys.argv1. It's just one. I just want the first thing. File name equals this. If file name actually, okay, so my sizes will be wrong, that doesn't matter. My neurons will be wrong, that matters. I think I have to save the neurons too. So neurons come first. I want to make this a class method, which means it doesn't take self, it takes class. Net equals, so I want to make a new one, and it needs to have, it doesn't matter what it has, because these will be replaced. And then it returns a net. These will be messed up. But I guess we don't need them. Okay, so if you have a file name, then net equals network.load file name. Otherwise, we want to load the data and do the training. All right, let's see if that works. Kill this. It should let me play with it even though it's not done. Prompt cloud I. Okay, it's not very good, but it didn't train for very long. And it only has 80 neurons actually. Hehehe. Here the planet, the was, and the one, and the pissing. The was and the with and the good, the planet. Does it have pissing in the training data? No. What? It just invented this word. What? It has pissed, piss. It doesn't have pissing. It has piss in. That's interesting. And did it memorize anything? Let's see. No. All right, we'll kill that. This should let me train a network. Oh. That makes sense. If sys.arg, if len is greater than 1, else none. So after 1 or 2 epochs, we'll kill it and then save it. Okay, that's as much patience as I have. What does it know now? It knows to say, what do you got of the Rome to store in the worky? So now we kill this, save network as test. Didn't like that. Setting an array element with a sequence. The requested array has an inhomogeneous shape after 1 dimensions. The detected shape was 2 comma plus the inhomogeneous part. What's the problem with that? Why is that not allowed? I don't really get it. np.save. Oh, I guess now that I think about it, weights is a list. So it doesn't really make sense to save, like you shouldn't numpy save a list of weights. You should iterate over them and numpy save them. So it's like self, how would I say this? Am I allowed to save just a number? F len of self dot neurons. And then start by loading that. Num equals np.loadf. So that I can understand what I'm loading. So that basically, oh, I was already loading the neurons. Neurons is a list. These are all lists. So what I want is for n in self.neurons. Save. Actually, you can just save them all one at a time. For I in range, here, num equals this. Save num, and then for each I in num, save them separately. And then here, load them separately. So define all these things. And then append the things you're loading one by one. Possible? Okay, we kill it immediately. I'll get a chi to the aught the plate. Kill that, save that as test. Saved. Okay, now run this with test.npy. Okay. This is missing layers. So I'm just gonna pass in nothing. All right, now we're having trouble loading. Object arrays cannot be loaded when allow pickle equals false. What does that mean? So I just need to add allow pickle equals true for all of these. Cloud I. I did not successfully load the neurons. And now that I think about it, these aren't NumPy objects. So it would be hard to load them. Or I don't know what save and load does on non-NumPy objects. Did I have to say pickle when I saved it too? Allow pickle equals true. Maybe those are the only ones where that matters. Since those are the only ones that are not Python objects. This isn't gonna work. I need to save, or I need to save it with the allow pickle. Okay, kill that. Get an example. Dot 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 dot. Let's try to get a better example. Hello, my name is. How about avalanche is in the under some fire. Kill that. Save it as test. Load it as test. Avalanche is. I'm still not loading the neurons properly. I mean, I wonder what they look like. Print net.neurons. ReLU softmax. That seems right to me. What does the f function look like? It thinks it's an ND array. Oh. Wait, why does it think that? Why does it think it's an array? Maybe just because that's how save and load works. So do I have to load it and then grab the 0th thing? No. It thinks it's a ReLU, but then it thinks it's an ND array. NumPy save array. Or I guess I want to save a not NumPy array. We saw save Z here, but was it? Save several arrays. I don't get it. What's the difference? Why am I having so much trouble with this? This shouldn't be that complicated. I don't understand this. I don't know why this thinks it's a ND array. NumPy save object. I don't get it. So it does think you need to save an array when you do numpy.save. The nice thing about .save is that I can do it multiple times and then it'll remember it by order. Save Z looks like I can store stuff that's not an array. No, not really. It still wants them to be arrays. Okay, I have to do dot item according to this random thing. Any chance that's true? Class type. Okay. Oops. Okay. Dot item. So here, dot item. Okay, that's not right. It loaded, but it loaded incorrectly. How did that happen? So nothing said that you have to allow pickle while saving. Why is that different? Wait a minute. Oh, it's giving different things each time. So how am I loading it in a way where that could happen? I mean, I wonder if I have to do dot item for all of these. No, because these are actual NumPy arrays, so I shouldn't have to. I mean, this one isn't. I could see this needing that. It's so interesting that it's different every time. I mean, my velocities are going to be messed up. My weights and my biases are going to start as random. So maybe that is what's happening and they're not getting set properly. Because here they're random. And then I'm trying to replace them. But maybe that's not working for whatever reason. Net dot weights. Println of net dot weights. 2. I just want to see if it is the same every time. But that's going to be hard to tell. Last number is negative 1.42. Yeah. Okay, the weights of the 0th thing look like they're staying the same every time. These look the same also. Could the biases... The first one is negative 2.14. Kill. First one is negative 2.14. So if the biases are not changing and the weights are not changing, ends on 0.014. 0.014. If the biases and the weights are not changing, then why would the outputs be different each time? What else contributes to that? Oh, is the vectorization different each time? I think it could be. All characters. Yeah, they're different each time. Okay, sort them. Sorted. Or yeah, let's remove this. SJS, kill that. SJS, okay, so now it's consistent. The thing I have saved is not gonna work because it was trained on a different vectorization. But if I train a new one and overwrite it, maybe this can work. Okay. After one epoch, I'm gonna kill it. Kill. What is something you can say? Hello. Hello, my. Well, the one on the share. Kill you, save you as test. Load you as test. Hello, my. The one on the Shrere. Beautiful. Save and load complete. Okay. So, pretty cool. There's a little bit of cleanup that I could do now while we're here. So get rid of some to-dos. This is not right, this cost function, I think. Well, it kind of is, but it's not right with a softmax. Just gonna get rid of that. Dropout never really worked, and it also is not using the batched implementation. So I'm just gonna get rid of it. This weight initialization doesn't really make sense for ReLUs. I think this only works for sigmoids or something. We can pull this up. In practice, it never helped us. Where is it? Here. For hyperbolic tangent units is this, and for sigmoid units this, but we're not using either. What if I just Google weight initialization ReLU? Is there a good method? Oh, stack of chains. How should you do it for ReLUs? They're not going to make it as easy to understand as that paper, I guess. I don't know how to read this. Ah, this is easier to understand. Square root of 2 over fan in plus fan out. There is no universal best choice. What am I doing right now? I'm doing square root of 1 over... Is this fan in? I think this is fan in. So they're saying like you could try 2 over x plus y, for example. How does that do? I want to try training faster. I'd have to get rid of some training data. Let's just copy this. This would be for sigmoid. This is for ReLU. And it's called... This one is called glow-rot normal. $44, like, is that good? Who knows? Oh, I guess I was using LeCun before. So let's just do that. It seemed fine. Like, and this one is 1 over square root of just x. All right, kill this. How did you do? Interesting. All right. Sure, we'll save you as test. You're the best one so far. Okay. Okay. So here's where we are. Or, this isn't where we are. This is where we're going. This is what a transformer looks like. And my understanding is large language models use transformers as their architecture. So if we look at what do we have so far and what's left for us to build, first of all, I don't have a unique, I don't have an understanding of how this works yet. I've got these two diagrams that are both describing the transformer model. So this one is from the original paper. I think the attention is all you need paper. And this one is from Wikipedia, and they look slightly different. But I think they're describing the same thing. So as far as they're different, it's probably me not understanding things. If we look here, softmax is the final step. The thing we're doing, softmax is the final step. So if we're working backwards, we're good up to this point. Linear is the step before that. Linear is something that we've implemented. So we have linear layers. I actually think that the way we're implementing softmax includes a linear inside the softmax. So I think the reason I think that is we're going to have weights and biases on the softmax layer. Yeah, we're going to have weights and biases on the softmax layer because we have weights and biases on every layer. So I think a layer that has weights and biases is just called a linear layer. So I think we actually have the network up to here as just our softmax layer. Then each of these blocks is repeated n times. So if we can make the things inside these blocks, we just have to stack them multiple times, and we'll get our, I think the left side is an encoder and the right side is a decoder, but I don't know what that means yet. Feed forward, I think this just means stack a bunch of ReLU layers, because a bunch of stacked ReLUs is an example of a feed forward neural network. Right now, everything we're doing is a feed forward neural network. So the fact that this says feed forward, I think just means stack a bunch of ReLUs or whatever you want as a regular neural network inside here. So I think we can do these blocks. Multi-headed attention. And here, these two blocks look the same, but in the Wikipedia version, this is called multi-headed cross-attention. This is called multi-headed self-attention. And this is called masked multi-headed self-attention. I don't know what those mean yet. So we're going to have to learn how to make a attention layer. And maybe when we do, we'll understand what makes an attention layer masked and what makes it self versus cross attention. Actually, now that I'm looking at it, I wonder if cross attention just means the V, the K, and the Q don't all come from the same place, and self attention means they all come from the same place. That would explain it. But anyway, not there yet. I don't know what attention means. Then two other pieces that we have not implemented yet are norm and these pluses. However, I've been doing a little bit of reading between streams, and I think I know how to implement norms and pluses. So those are going to be the next things we do. I think pluses will be easy to implement and norms will be annoying to implement. But yeah, we'll get to that next. Then what else do we have? We have this positional encoding stuff. That I don't know what it means. I have a vague idea that the reason a positional encoding is needed is to tell the network basically which letter are you on. But I don't really get it. I don't know. I don't really get it. And then embedded / projections. I have an idea of what that means. Like for our neural network, we just said that a letter is an atomic unit, and we have a vector with an 87 dimensional vector where you're always pointing. You have 1 in one axis and 0 in the other axes. That's like our embedding, I think. That's how we embedded English into vectors. Is one letter at a time vectors. So a word is like we kind of don't have a concept of a word. We just have 20 characters at a time. And a word would be like, if you look at where the ones are in that vector, you could see where a word is. So it's very redundant because it's a really high dimensional vector and it's mostly zeros. I think there's better ways of doing embeddings where it's more dense, where like a vector doesn't where how do I say this? It's like where it's more dense, where the vectors are more I don't know how else to say it. I'm trying to think of a different way to say more dense. But it's not just a bunch of zeros and a 1. It's like a vector is a thing that's pointing in a specific direction, and it means a word or a list of letters or a list of tokens or something. Like there's this thing called word-to-vec, where our embedding could be that every word is a vector. So I don't really understand this. That something that I think I know about word-to-vec is that it's semantic embedding, meaning like if you looked at the high dimensional vector space and you had a vector pointing this way, and this vector represents the word king, and you have a vector pointing this way, and this vector represents the word wife, that if you combined them together into a vector pointing this way, like if you sum them together, king plus wife equals queen. So it embeds the words into a space that encodes their meaning, so that words with similar meanings are pointing in a similar direction. And you can do linear algebra on them. Like you can add words together and it becomes a vector with pointing in a direction of the word that has the meaning of those combined words. So that seems like it would be a good way to do embeddings, because then you could learn, like the reason we're not doing we're not converting this into ASCII, which would be another dense way to pack the vectors, is that you can't, then we're forcing our network to learn ASCII. So like if it gets close but not quite right, it's outputting gibberish. Whereas if you were close but not quite right in a semantic embedding, you would just get a different word that means the same thing. Which makes it easier to learn because you can be close. Whereas with ASCII, you can't be close. You're either exactly right or you're wrong, because a single bit flip changes the letter completely. So that's what I think embedding / projections means. And I don't know how to do that. Or I don't know how to do anything better than what I'm doing here with the character by character thing. But we've gotten good results so far with the character by character thing, way better than I thought we would. So that means there's a bunch of stuff left to learn. But the next things are just going to be this plus, which in here they call it add and norm. Here they have it as separate steps, the add and the norm as a separate step. Something I noticed is that here in the Wikipedia version, you start with a norm and then you go into attention. In the non-Wikipedia version, you don't start with a norm. So I don't know if that's, I don't know which one's right, or maybe it doesn't matter whether you do it or not. I don't know. Okay. So why don't we call it a day for now, and next time let's do add and norm. I found some resources. I think I'm going to be able to do it. I think I understand what they are, so I'll explain them and we'll see if we can implement them together next time. But that's going to be it for now. I hope this was helpful. Peace.